Hey everyone, this is section 2.1 on functions. And so in this section, what we're going to do is look at what is a function, what are the things that are required for something to be a function, and then how can we actually use those functions in even some real world situations to help us solve some problems. Okay, so we'll start out here with what's the definition of a function. So a function is a rule that it's going to assign each element x, okay, which is going to be a set A, exactly one element called f of x, which is in a set B. So in other words, for every x value of your function, there can only be one y value. Okay, so if there's ever more than one y value for a given x, then we no longer have a function. Okay, so for every x, there's exactly one y. That's what this definition tells us. All right, so we have a function here defined by the formula f of x is equal to x squared plus 4. So the first thing it asks us to do is express in words how f acts on the input x value to produce the output, which is the f of x value. All right, so if we think about our order of operations here, right, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, the first thing that's going to happen to our x value is that exponent. Okay, so we're going to get our exponent here is going to square our x value first. So the first thing is we square the x. Right, now, once we've squared that x value, the next thing we have in this function is addition of 4. Right? So then the next step is we're going to add 4. And that's all, right? So in describing it in words here, we're going to square the x value, we're going to add 4, and that's all we have to do. Right, so now the next piece of this is we want to evaluate f of 3, f of negative 2, and f of square root of 5. Well, if we're looking at f of 3, notice that 3 is in the place of the x value, right? Because this is an f of x function. So we're going to substitute that 3 everywhere we see an x value. So this is going to give us 3 squared plus 4. Again, following order of operations, the first thing we do is square the x value, and then we're going to add 4. So if we square the 3, that's going to give us 9. And then when we add the 4, that should give us 13. And so f of 3 in this case is equal to 13. Okay, now we want to find f of negative 2. We're going to do the same thing. We're going to substitute negative 2 in place of the x value. Again, follow your order of operations. Negative 2 squared, notice here we're squaring the negative value also. That's going to become a positive 4. And then our next step is to add the 4, and so that should give us 8. Okay, so just be very careful when you're substituting negative values. In this case, because we're squaring it, we're squaring the entire x value, including the negative. It actually becomes a positive there. Right, and then the last one here, f of the square root of 5. Again, I'm going to substitute square root of 5 for x. When we square a square root, right, those are inverses. They're going to cancel each other out. And so the square root of 5 squared should just give us a positive 5. And then when we add the 4 here, that should give us 9. So f of square root of 5 is equal to 9. All right, now the next piece of this one is we want to find domain and range. Okay, so when we talk about domain, this is telling us we're looking for all of the x values of our function. So what are all the possibilities of x? Well, if we look back at the original function, right, the only restrictions we've talked about so far are if we have an x in the denominator or if we have an x under a radical. In this case, we have an x squared plus 4. We have no x's in the denominator. We have no x's under a radical. So in this case, there are going to be no restrictions on our domain. And so we can say that this is all real numbers or from negative infinity to positive infinity. Okay, so that's the domain. Now we need to think about range. Now, in order to think about range, it's probably easiest just to think about what the graph of this function would look like. Okay, so if you were to graph this one, this is actually going to be the shape of a parabola, a U-shaped graph. And then the plus 4 tells us now that the vertex is actually going to be at positive 4. So we're going to have a parabola that starts right here. And it opens upward like this. Right? This is just a rough sketch, just to give you an idea of what the graph looks like. Now, if you use Desmos to graph this, that would work. If you use your graphing calculator to graph this, that would work. Right? So just whatever you need to do to see what this graph actually looks like. Now, since we're thinking about range, now we're thinking about the possible y values of this graph. We'll notice none of our y values on that curve are below +4. So we know in this case that our range is going to start at +4. There is a point at +4, so we're going to include it. So our range this time is a bracket with a 4. And then it's all the values bigger than 4, so we're going to go up to +infinity. Remember, infinities always have parentheses. Okay, so we include the 4, and then infinity gets a parentheses. And this is the range of that function. And then the last piece here, just drawing a function machine. Basically, we're inputting an x value into our machine. And then that box here tells us what we're going to do. Well, that goes back to that expressing in words what's happening here. So we're going to square the x, and we're going to add 4. And then once we do that, that's going to output whatever f of x value we want. Okay, so that's what it means by draw a function machine. There are some in WebAssign that will ask you to kind of describe what's happening there, or possibly choose the right function machine. So just understand, right? That's what they're looking for. Or maybe even they give you the function machine, you have to match the function to it. So that's all that is. Okay. All right, example 2. Now we want to let f of x equal 3x squared plus x minus 5. We're going to evaluate each one of these values for that specific function. Okay, so the first one here is f of -2. Again, remember the -2 is the x value now, so we're going to substitute it in place of all of our x's. Now we've got 3 times -2 squared plus, now I have another x, so that also becomes -2, and then we have our minus 5. And just like the previous one, just remember when we have a negative value, just be very careful, put it in parentheses, because when we square that value now, it's actually going to become a positive. Okay, so our order of operations here, we're going to square that first. So we'll have 3 times -2 squared becomes +4. Plus a -2, I can just write as a -2, and then we have our minus 5. Then our next step in order of operations, we're going to multiply. So 3 times 4 is going to give us 12. -2 minus 5. And at that point, we have all subtraction. So now I can just go left to right. So 12 minus 2 is 10. Minus 5 should give us a +5. So this would be our value now for f of -2. We're going to do the same thing with each of these other ones. For f of 0, we're plugging in 0 for x. So we'll have 3 times 0 squared plus 0 minus 5. Again, follow your order of operations. 0 squared is going to give us 0. So now we have 3 times 0 plus 0 minus 5. Next would be multiplication. So 3 times 0 is 0. So we have 0 plus 0 minus 5. And at that point, we have all addition and subtraction. So we're going to go left to right. 0 plus 0 is 0. Minus 5 should give us a -5 this time. All right, now if we do f of 4, we're going to substitute that in everywhere we have an x. So 3 times 4 squared plus 4 minus 5. Again, order of operations, 4 squared comes first, so that gives us 3 times 16 plus 4 minus 5. We do our multiplication this time. 3 times 16 is 48. We have 48 plus 4 minus 5. And now we have all addition and subtraction, so left to right. 48 plus 4 should give us 52, and then 52 minus 5 should give us 47. And then our last one here, f of 1/2. So now we have 3 times 1/2 squared plus 1/2 minus 5. 1/2 squared, remember 1/2 times 1/2, we can multiply straight across. That would give us 1/4. So we have 3 times 1/4 plus 1/2 minus 5. Then we would do our multiplication. So 3 times 1/4 is going to give us 3/4 plus 1/2 minus 5. And at that point, we need a common denominator because we're just adding and subtracting. So our common denominator between all of those terms would be a 4. So I'm going to keep my first one here as 3/4. 1/2, we would have to multiply top and bottom by 2. So that's going to give us 2/4. And then for the 5, we would have to multiply top and bottom by 4, because remember, we could think of this as 5/1. So then that would give us 20/4. Now we can just add and subtract. Okay, and so remember with these, with addition and subtraction for like denominators, we can just add and subtract the numerators, keep the common denominator. We have 3 plus 2 is 5, minus 20 is -15. We're going to keep that over our common denominator of 4, and so -15/4 would be our answer there. Now, feel free to use a calculator, to double check yourself on these also. I would also accept a decimal for this one. So in this case, that should give you -3.75. All right. Example 3. All right. So this is what we call a piecewise function. Okay. And so you can see that written up here, piecewise. So anytime you have a piecewise, what happens is we have different pieces of our function defined for different parts of our domain. So notice the top part of this function, the top piece is 39, but that's only when x is between 0 and 2. And then the bottom piece of our function here is only when x is greater than 2. And so what we have to think about whenever we're calculating values for these piecewise functions is which piece of our domain does our x value fall in, and then that's going to tell us which piece of the piecewise to actually use. Okay, so we have a cell phone plan here that costs $39 a month. Plan includes 2 gigabytes of free data, but then charges $15 per gigabyte for any additional data that we use, right? And so that's why we're defining this function from 0 to 2 at $39, because we have a flat $39 fee as long as we're not going over 2 gigabytes. But as soon as we do go over 2 gigabytes, the x is greater than 2, then we have to charge ourselves an additional $15 for every gigabyte that we go over, right? And that's what that bottom piece of the piecewise does. Okay, so now if we're looking at C of 0.5, in this case, 0.5 falls somewhere between 0 and 2, so that tells us now that we're using that top piece of our piecewise function. Well, in this case, that's a flat fee of $39. There is no x to substitute into, and so C of 0.5 is just going to be 39. So basically, if we were to use 0.5 gigabytes of data, then we would be charged $39. Okay. The next one is C of 2. Now, in this case, 2 is equal to 2, right? And so that still tells us that we are using the top piece of our piecewise function because we're not greater than 2 yet, right? We're still between 0 and 2, including 2. And so again, that's still going to be that flat fee of $39. We're still using that top piece, which is just equal to 39. Now the last one here, C of 4. Now we are bigger than 2. So now we have to look at this bottom piece of our piecewise because our x value is greater than 2. And so now we're actually going to substitute 4 into that bottom piece of our piecewise. So we've got 39 plus 15 times 4 minus 2. We follow our order of operations, do parentheses first. 4 minus 2 is 2. So now we have 39 plus 15 times 2. Next would come multiplication. So we have 15 times 2, which is 30. We have 39 plus 30. And then finally, we can add those together. And so that should give us 69. Now, in this case, because all of these are actually a real-world problem, right? We're trying to figure out what these values represent. These are dollar amounts because this is telling us how much we would actually be charged for that many gigabytes of data. And so for each one of these now, I'm going to say that first one's $39. Same thing with C of 2, that's $39. And then finally, this last one's going to be $69 if we were to use 4 gigabytes of data. So just always think about your units, especially on your word problems. Make sure that you understand what your final answers are actually representing. All right. Now, net change. Okay, so the net change in the value of a function as the input changes from a to b is given by the function f of b minus f of a. Now, remember, an f of x value is just like a y value, and so we're basically just finding the difference in our y values where we're going from a to b now. So that's what net change tells us, is how much is the y value changing as my x value goes from a to b. So here we've got a function, f of x equals x squared. We want to find the net change between 1 and 3. The first thing we want to do is identify what's the a value, what's the b value. Well, in this case, a is going to be 1, b is going to be 3. A will always be the smaller of your x values, and b will always be the larger of your x values. So to find our net change, we're going to do f of b minus f of a, which in this case would be f of 3 minus f of 1. So now it's just a matter of actually substituting those values into our function to find f of 3 and f of 1, and then we can subtract. Well, to find f of 3, I'm just going to substitute it into my x squared function. That's going to give us 3 squared. And then if I do f of 1, I'm substituting 1 into my x squared function. That's going to be 1 squared. Now we're going to simplify. So 3 squared should give us 9. 1 squared should give us 1. And 9 minus 1 is 8. And so our net change is going to be 8 this time. Same process for the next one. We're trying to find the net change between -2 and 2. So again, our smaller value is going to be the a, the bigger value is going to be the b. So now f of b minus f of a is going to be equal to f of 2 minus f of -2. Okay, so just be very careful with the order of these, right? Always start with the f of b, which is the f of the larger value. And so again, we're going to substitute that into our function. That's going to give us 2 squared minus, and then f of -2, again, make sure you put the -2 in parentheses because we're going to square that whole value. Now we simplify. If we do our exponents, 2 squared is going to give us 4 minus, and then the -2 squared becomes a 4 also. And then 4 minus 4 actually gives us 0 this time. And so our net change from -2 to 2 is actually 0. Now, the reason for that is that the y values at f of 2 and f of -2 are exactly the same. And since we're looking at the change in the y values, we're just saying, yeah, the y values haven't changed from -2 to 2 because they're exactly the same y value. They both give us 4. All right, example 5. Okay, so now we've got our function 2x squared plus 3x minus 1. And again, we're going to evaluate each of these functions. Now this time, notice we've got variables instead of actual numbers. Okay, so we look at f of a. All that tells us is that a is going to go in place of all of our x's. So in this case, when I do that, I get 2a squared plus 3a minus 1. And at that point, we're done. And the reason is there's nothing to simplify. Since we're not substituting an actual number in there, we can't square anything, we can't multiply anything. That is simplified. That is our final answer for f of a. Let's look at f of negative a. So now we're going to have 2 times, and again, because it's a negative, I'm going to put it in parentheses, negative a squared plus 3 times negative a minus 1. Now this time, because we've got those negatives, we could simplify this a little bit. Okay, so that negative a squared, remember when we square a negative, it's going to become a positive. So this is actually 2a squared. That 3 times negative a, we could just write as a negative 3a or a minus 3a, minus 3a, and then finally the minus 1. So in this case, because we had the negatives, we could do a little bit of simplifying. But again, once we get it down to just these a squares and a terms, now we're done because there's no actual numbers to simplify there. Okay. All right, so this next one now, I'm actually going to call this a plus h instead of a plus b, just so we can use it when we get down to the last one here. So if I do f of a plus h, in place of all of my x's now, I'm going to substitute an a plus h. So we have 2 times a plus h squared plus 3 times a plus h, and then we're going to have our minus 1. All right, now this time we can actually clean this up a little bit. Okay, so I actually want to simplify this sum. So I'm going to take that a plus h squared and I'm going to simplify it. Okay, now if you remember back to the previous chapter, we have a formula where we can actually figure out the value of a plus h squared. If you forget that formula though, just remember a plus h squared means a plus h times itself, right? So a plus h times a plus h. So when we do that now, we're going to have to use FOIL. So we'll do our first terms, a times a is going to give us an a squared. Outer terms, a times h is plus ah. Inner terms, h times a, same thing, ah. And then our last terms, h times h, would give us an h squared. And now we have like terms in the middle, ah plus ah. That's going to give us 2ah, so a squared plus 2ah plus h squared. And again, that's the same thing you would get if you use that formula from the last unit. Okay, but again, if you forget the formula, just think you're multiplying a plus h times itself and then just use FOIL. So now this is going to give us 2 times what we just calculated up there, a squared plus 2ah plus h squared plus, and I can go ahead and distribute this 3 now to the a and the h. So we're going to have a plus 3a plus 3h, and then I just have my minus 1. Okay, now the next thing we can do is we can distribute the 2 into that set of parentheses there. So we're going to have 2a squared plus 2 times 2ah is 4ah. 2 times h squared is 2h squared. We have our plus 3a plus 3h and our minus 1. Now, always look for like terms. Make sure you can't combine anything else. In this case, though, none of those are like terms. There's nothing else we can do to simplify this. That would be our final answer for f of a plus h. All right, and then the last one here, we have f of a plus h minus f of a, and then we're dividing all of that by h. And now notice here they tell us that h can't be equal to 0. That's just so we don't end up with a 0 in the denominator, okay, because we can't divide by 0. So if we calculate this one now, we're going to start with f of a plus h. Well, this right here is exactly what we just calculated right here, right? This was f of a plus h. So I'm just going to put this all in place of f of a plus h. We have 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. Now I'm going to subtract f of a. Okay, but f of a, again, we've already calculated. This up here is what we got for f of a. So I'm just going to say I'm subtracting now. And notice I'm going to put parentheses around this because I want to make sure I'm subtracting the entire f of a function. So 2a squared plus 3a minus 1. And then all of that has to go over h. All over h. All right, now I'm going to distribute out that negative sign into my set of parentheses. So when we do that, we're going to get 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. Distributing the negative gives us a minus 2a squared minus 3a. And then when we distribute that minus to the minus 1, that becomes a positive 1. All over h. All right, now I'm going to combine like terms. Okay, so if we look here, we have a 2a squared, but we also have a negative 2a squared. So 2a squared minus 2a squared, those terms are going to cancel each other out. I also have some a terms that I can combine. We have a positive 3a and a negative 3a. Those two terms are going to cancel each other out. And then finally, we have a negative 1 and a positive 1. And a negative 1 plus 1 becomes 0, so those terms cancel each other out. All right, now I'm going to create a new slide here so we can finish this one out. All right, so what we were left with was 4ah plus h squared plus 3h. I'm just going to go back and make sure that was all correct. It was a 2h squared. Make sure I get a 2 in there. This middle term is 2h squared. And all of that was over h. Okay, so once we combine like terms and cancel things out, okay, that's what's left now. Now, if we look at our numerator, we actually have a common factor. So we can actually factor out an h in the numerator. So if I factor out my h from the 4ah, that's going to leave us with 4a. Factoring out an h from 2h squared leaves us with 2h. And then factoring out an h from the 3h is just going to leave us with a plus 3. And all of that is over h. And now, because we have a common factor of h in the numerator and the denominator, those are going to cancel each other out. So I can cancel out my h terms. And so all that's left is the 4a plus 2h plus 3. And so this right here would be our final answer for that entire expression, right, which was f of a plus h minus f of a all over h. That's what we were calculating there. Now, the reason that this is so important is that if you do decide to go on and take calculus, that formula right there is what we call the difference quotient, and we actually use it a lot when we're calculating certain things in calculus. Okay, so being able to actually work with functions, substitute into that function, and actually simplify it is extremely beneficial when you get to calculus. All right, example 6 now. So the weight of an astronaut. So an astronaut weighs 130 pounds on the surface of the Earth. Her weight when she is h miles above the Earth is given by the function, right? And so this is a pretty complex function here, 130 times 3,960 over 3,960 plus h, all squared. Now we're asked to find her weight when she's 100 miles above the Earth. Now notice here, h represents the number of miles above the Earth. So all we really have to do in this case is take that 100 and substitute it into our function wherever we have an h. Okay, so we're finding w of 100. And so we're going to start here with 130 times, we have our 3,960 in the numerator, over 3,960 plus h, which in this case is 100. And then we're going to square that. Now, if we do all of that, that should give us 123.67. Okay, or if you just want to round it to the nearest pound, that would be about 124 pounds. Okay, now, if we wanted to construct a table of values for that function that goes from 0 to 500, then you would just make a table. You would set your values at 0, 100, 200, 300, 400, 500 for your h values, substitute those in, and then actually find what those weights are. Okay. I want to focus now on this last piece, the net change in the astronaut's weight from ground level to a height of 500, right? Because if we can calculate the ground level and the 500, right, that's the main thing I want to think about this time. Well, in this case, ground level would be a height of 0, right? Because we're 0 miles above the Earth. So I'm going to let this be 0 miles. And we want to go up to a height of 500 miles. Well, net change, remember the formula is f of b minus f of a. In this case, the a value is the smaller of the two, so that's going to be your 0. And the b value is going to be the bigger, which is the 500. So we're really just finding w of 500 minus w of 0. Now, again, at that point, we're substituting into that function, right? So we would substitute 500 in place of h. And if we do that, that should give us approximately 102 pounds. Then we have minus, and then if we substitute 0 in there, that's actually going to give us 130. Because if you think about it, right, she weighs 130 pounds on the surface of the Earth. When we substitute 0 in there, we should get 130, which we do in this case. Now it's just a matter of subtracting. And so if we do 102 minus 130, that's going to give us a negative 28. Now, again, I want to think about our units here, right? So we found the net change in our W values, which are the weights. So this is negative 28 pounds. What that tells us in the context of this problem now is that as I go from 0, right, 0 miles above the Earth's surface, to 500 miles above the Earth's surface, my weight is going to drop by about 28 pounds. That's what this net change represents. All right, example 7. Now we want to find the domain of each of these functions. Okay, so if we look at the first one here, remember our restrictions from the previous unit. We know that denominators can't be 0. We know that radicals can't have negatives inside, right? So we look at the first one, we have a denominator with an x in the denominator. I'm going to say in this case that x squared minus x cannot be equal to 0. Now, to solve that equation, because it's quadratic, it has an x squared in it, I'm going to have to factor first. Well, my common factor here is x, so we're going to have x times x minus 1 cannot be equal to 0. And then just like if this was a quadratic equation, right, instead of a not equal to, we could just set each one of those factors equal to 0. In this case, we're going to set them not equal to 0. And so our first one's already solved. X can't be equal to 0. And then this one, if I add 1 to both sides, that tells me that x cannot be equal to 1. So now in terms of our domain, we can be any real number except 0 and 1. So I'm going to start my domain from negative infinity. It's going to go all the way up to that first restriction. The smaller of those restrictions is 0, so negative infinity to 0. And I don't want to include 0, so I'm going to use parentheses. Now I need another interval, so I'm going to use a union that starts from 0 and goes to my next restriction, which is 1, right? So don't forget this interval, because technically there are a whole bunch of decimal values that fall between 0 and 1 that still work in that function. So we need that interval from 0 to 1 also. And then finally, we need another union, and we're just going to go from 1 all the way up to positive infinity. So now we've included every single value except for 0 and 1. So that's what the domain of that function would be. All right, now our g of x function, notice here we have a square root, right? So in this case, we know we can't have negatives under the square root. So 9 minus x squared must be greater than or equal to 0, right? Because it's not in the denominator, so it could actually be a 0 inside the square root. Now, again, I'm going to factor this. This is a difference of squares, so we're going to have 3 minus x times 3 plus x must be greater than or equal to 0. At that point, thinking back to our inequalities from Unit 1, we're going to set each one of these equal to 0. So 3 minus x equals 0, 3 plus x equals 0. I'm going to get the values here. That's going to be x equals 3 or x equals negative 3. And then I'm going to create my number line. Negative 3 is the smaller value, positive 3 is the larger value. Now we have to test points. So I'm going to choose a value down here of negative 4, and I'm going to substitute it into my factored form. If I do 3 minus negative 4, that becomes 3 plus 4, which is a positive value. And if I do 3 plus a negative 4, that's going to give me a negative value. A positive times a negative is going to be a negative, so everything in that interval is going to be negative. Okay, now I'm going to choose a value between negative 3 and 3. 0 is a value between negative 3 and 3. If I plug in 0 into that factored form, 3 minus 0 is positive. 3 plus 0 is also positive, and a positive times a positive should give us a positive. And then finally, I'm going to choose a value of 4 up here. 3 minus 4 should give us a negative value. 3 plus 4 is a positive value, but a negative times a positive is a negative. Now, in this case, we want it to be greater than or equal to 0, which means we only care about positive values. So that tells me now that my interval is going to go from negative 3 to positive 3. And because it was greater than or equal to, I can actually include my endpoints this time. So negative 3 and positive 3 are both going to get a bracket. And then our last one here, we also have a square root this time, but it is in the denominator. So in this case, that t plus 1 can't be greater than or equal to 0. It can only be greater than 0. Right? Because if it was equal to 0, then we'd have a 0 in the denominator. If I subtract 1 here, that's going to give us t is greater than negative 1. And so that just tells us then, in terms of our interval notation, that we're going to start from negative 1. We're not going to include it, so we need a parentheses. And then we're going to go up to positive infinity. So notice this time, because it was just a simple inequality, a t to the first power, you don't have to do the number line test and everything. We only have to worry about that if there's a square there. Right. So that's it for section 2.1. As always, please let me know if you have any questions. Send me those questions through WebAssign, drop in during student hours, whatever you need to do. But I will see you next time for section 2.2.